It's hard to imagine anyone who does not have a friend or a loved one that has not been addicted and perhaps died of it. And that's why the state of Minnesota, for the task for the land-grant medical school here, one of them was this: figure out this addiction and figure it out as something that is based on understanding. And that confidence in science has really been what fired up these medical discovery teams.
Yeah, this is a really long-term effort that involves a lot of different people around the world working on this topic. And the University of Minnesota has the world's best brain imaging centers. So as part of this effort, we've assembled a team of people who are leveraging that asset to do brain imaging on people with substance use disorder so that we can understand what brain changes are happening with drugs and then find new targets for therapies.
To change that fate by rewiring the brain in a way that it actually is not addicted anymore. And that would be the first time in history of mankind that we are able to do that.
So we're interested in some of the drug-induced plasticity that takes place. We know that drugs of use change the brain, but hopefully there are ways that we can revert some of those changes and actually be able to kind of impact relapse and prevent relapse going forward.
It's very empowering to know that what's happening to someone who's suffering, it's a biological effect, and we're coming to a better understanding of that. I think it gives people hope. It gives them an understanding that this isn't a moral failure, this is a biological failure in a way. So by virtue of doing this work and by spreading knowledge about it, I think that helps. The reward center, it's deep in the brain, a small but powerful center that receives dopamine signals. So these drugs are tapping into this circuit that's been around for a very long time and supports our very survival. And that is what we think makes them so difficult for some people to abstain using. And the interconnected activity between these regions is something we can more easily study now than ever before because of some of the new technology that we have.
We have discovered certain patterns that really can tell us something about the struggle people go through when they are dealing with stress and when they are dealing with withdrawal, how that constellation of symptoms predict their ability to cope with abstinence or the risk for relapse and maybe surviving in recovery for a long period of time.
In my laboratory at the University of Minnesota, we've been developing a series of vaccine targeting various opioids. These drugs of abuse are too small to be seen and recognized by our immune system. And so we take a target opioid, we modify it so that it allows attachment to larger structure. So the antibody is bound to the drug and would have no effect, or some of other toxic effects that are related to overdose.
You provide some path for people. You bring in discipline, and it can be knowledge-based, it can be science-based, but that order is really an important thing because people do well when they have some focus around themselves, and we will get through this.
I am very hopeful. That's what sustains our interest, is hope that we are increasingly acquiring knowledge and information, and we're all working on the same problem.
There is a sense of urgency that comes with the fact that if we don't do something about this, this will be something that we will leave to our children and grandchildren to deal with.
If we maintain this trajectory, and I have no reasons to believe we would not, I think we are going to have an impact at improving people's lives, not only in Minnesota, but in the country and globally. Science knows no boundary.